Graphing linear equations using 3 points or table of values. In this lesson, we are going to complete a table. Given the equation complete table, we pick 3 points. With 3 points doesn't matter, you'll still get the same line to graph the equation. Linear equation. Linear means a line. Equation has an equal sign. It can be solved. So linear equation, an equation for which the graph is a line. Solution. In the previous lesson, you have seen where we plug in the point to check if it's a solution in the equation, or if the point is on the line, then it's a solution. Or when we do our table of values, when adding or subtracting by constant number, does that point fall in the table? If it does, then it's a solution. So solution, any ordered pair of numbers that makes a linear equation true. So left hand side has to be the right hand side, or it has to lie on the line, or in the table. So here the question is 9, 0 is one solution. Is that true? Let's check. We have y equals x minus 9. This is our x, this is our y. So we plug in 0 equals 9 minus 9. So 0 equals 0. It's a solution. Both sides are equal. Linear equation. So example, we are going to graph y equals x plus 3 using table of values. So graphing, step 1, 3-point method. Choose 3 values for x. Graphing, step 2, find the solutions using the table. So you have y equals x plus 3. The points I chose was 0, 1, 2. So if I plug in 0 in this equation, 0 plus 3 gives me 3. Now if I plug in 1, 1 plus 3 gives me 4. If I plug in 2, 2 plus 3 gives me 5. What pattern do you see here? We are adding 1. We are adding 1. We are adding 1. A review. So our slope here is 1. Rate of change is 1. Our y-intercept is 3. So now we have our table of values. Now we are going to graph. So step 3 says graph the points from the table. So our points are 0, 3, 1, 4 and 2, 5. We're going to, so after we plot 0, 3, 1, 4 and 2, 5, we say the points lie in a line and it's increasing order. So the positive slope is increasing. Now step 4, after plotting the points, we are going to connect them. So after we connect the dots, you see it's just the points lie on a straight line. Okay, and it's an increasing function. Slope is positive. We saw it's positive 1. The rate of change is 1. Now let's try another one. Y equals 2x plus 1. This time the chosen points are negative 2, negative 1, 0 and 1. Instead of using 3, I'm going to use 4. So to complete our table, I'm going to plug in x values in place of x. X values in place of x. In place of x. So we have negative 2 times 2 plus 1. And then negative 1 times 2 plus 1. 2 times 0 plus 1 and 2 times 1 plus 1. So 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So y value is negative 3. 2 times negative 1 is negative 2. Negative 2 plus 1 gives us negative 1. And then 2 times 0. 2 times 0 is 0. 0 plus 1 is 1. And then 2 times 1 is 2 plus 1 is 3. So now we have our y values. We are going to plot. We are going to plot the points we have on our table of values. When we plot, we see our points lie on a straight line, and it's a increasing function, linear equation, increasing function, positive slope, going up the hill, positive slope. Now we connect our dots. Our next example, we are going to graph y equals negative 3x plus 1. This time our slope, this is in the form mx plus b. Slope intercept form, our m is negative, our y-intercept is 1. So we have a negative slope, our slope is negative 3 and y-intercept is 0, 1. We plug in x values, chosen x values is negative 1, 0 and 1. You can choose any number, but I chose negative 1, 0 and 1. In the equation y equals negative 3x plus 1. So in place of x, we are going to plug in negative 1, 0 and 1. So when we plug in x values in the equation, with the negative 1, x equals negative 1, we have negative 3 times negative 1, which gives us positive 3. Positive 3 plus 1 gives us 4. And then we have negative 3 times 0. For x equals 0, negative 3 times 0 gives us 0. 0 plus 1 gives us 1. And then we have x equals 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 gives us negative 2. So now we have our we have our y values, and we can graph. So when we graph our points, we can see it's a decreasing function. It's decreasing. So negative slope. Our rate of change is negative. It's going down the hill. Now let's connect the dots. So again, after we connect the dots, we can see the line is going down. It's a negative slope. Sometimes it's referred as linear decay.